Then, welcome everybody to my talk, Ceph Lessons Learned from Emergency Support. I will show some use cases of what we have seen in the last 2-3 years. And I just give a short introduction. I'm Joachim Kraftmayer. I'm the founder of the company Clyso. I'm also, or I was, a senior consultant for SUSE storage and a senior consultant for Red Hat storage. I do Ceph, I think now since 11 years. So I started around about 2012, did my first tries on it. And then I think since 2014, we run it in production. I think at this time, not so many people did it, but we learned a lot in the past. So. And when I decided to become the Ceph ambassador for the DACH region as well, I said, okay, then we should offer also an emergency support offer again. So, yeah, like I said, the company is founded in 2010, and our strict focus is on infrastructure and platform as a service with open source. We also are proud to support the open source community with all our forces, and also. Yeah, I'm happy that the whole team is really committed to open source. Yeah, we offer, especially for Ceph, consulting, development, managed service, training, support, and as mentioned before, also emergency support. Because sometimes bad things happen. Perhaps not that often, like 7-8 years ago, when an engineer really had fun to take care of his pet, but it still happens. I will just give you a brief overview what we have seen, and then some concrete examples. So, I think my colleague asked about who is running Nautilus. I mean, we have seen in the last 2 years still Joule. So Joule was also a quite good product before Luminous was released. I think Luminous was always the enterprise-grade version of Ceph, but yeah, we see sometimes Luminous around, and it is still working, sometimes 6-7 years without any updates. About this strategy we can talk perhaps later a bit, but yeah. So what we also have seen in the last year is that Ceph is running in virtual environments. If it's VMware, if it's OpenStack, if it's the hyperscalers, yeah, totally different setups from hardware. And deployed with all kinds of orchestration tools, with Rook, with DeepC, with SaltStack, with Ansible, manual installations, and also proprietary cluster managers that somehow integrated some when Ceph to manage them. So, and over 10 years I said, okay, you can do whatever you want with Ceph. As long as you know what you are doing, because I have seen too many stuff that Ceph can run somehow everywhere. So just the first example is that someone called us that they have tremendous performance problems. I think it was 2 years ago or something like this. And then we had a call together with them, and then they had only 3 OSDs in the whole cluster, and was complaining, oh, we don't have so much performance. They were, they used RAID 5 behind, so they missed the feature of Ceph that is completely transparent. Yeah, already someone is smiling. Yeah, also other ones that just a note to this. We transformed this cluster on the fly during production from this. With this hardware from 3 OSDs at the end to I think how many? We are next to 100 OSDs without any downtime, without any service interruptions and so on. So Ceph is quite capable to provide the service in a bad configured state, also when you migrate it in a better shape or state. So of course we see sometimes that's not, yeah. That there's not an understanding how PGs are, what are PGs for, how important they are for performance, and sometimes, like with the 28 active MDS servers, we realized that we see patterns that 1 is good, 2 is better, 10 should be much more better than 2, and 28 is for sure better than all the others before. So, yeah, but also it was working. It was the synchronization between the MDS was a bit heavy with this auto balance, with the auto balancing, but after we trimmed it, we brought it down, I think, to 8 or 10 active MDS with manual pinning. Everything was fine. So sometimes is the estimation or the assumption a bit wrong how to use Ceph, and it would be helpful, of course, to make it easier to understand. On the other hand, also it would be better sometimes to read the manual or join the Ceph, the Fahrlokon or a Ceph day. So, by the way, we will organize someone in Germany, I think in September. Hopefully we can do this. Yeah, to get better in touch with the community again, and yeah, and then you can learn from the guys who has a bit longer experience in production. Also, in setups, especially in completely automated setups, we have seen that there's a lot of trust in Ceph, that it's so clever and can even estimate what the customer wants to achieve without any information about this, especially when they create clusters or extend clusters across data centers, across availability zones, and so on. And sometimes they just missed, okay, Ceph tries to even distribute the data across all the OSDs or hosts or failure domains you define. And then you end up in an uneven scenario. Then you see, okay, why this host has 2 times more PGs than another one, or or you see, okay, it's not automatically not fulfilling my failure domain of a data center because I didn't define it. But sometimes the expectation is that it should have something like an AI that's already know, okay, how to do it upfront. But also, I mean, the crush map is quite complex, and I think 5 years ago I also did a small mistake, just switched to 0 with a 1, and because I think I did a lot of mistakes even before I tested my stuff as well and said, okay, is this really working like I expect that it should work? And I realized that because just changing one number, the distribution was completely different than my expectation. So on this side, it's always, yeah, please test everything before you bring it into production, and don't trust it just like this. It will somehow work. Then we have seen a lot of different hardware topics. I mean, it's an old story that with consumer SSDs, consumer desktops, Linux desktop, rotational disks, sometimes way too less CPU power, 1 gigabit network interfaces. That's also adding, I think, just from the technology stack, 70% more bandwidth. Or when you have MDSs that are in active replay mode, a 1 gigabit line is nothing in some cases. And we really had a nice problem with some rate controllers from a specific vendor. That's the reason also that I say, okay, if I can remove or can avoid something, I should not include it. Because this type of rate controller, I think it took over 14 months to fix the problem because they just stopped and rebooted and came back again. And that's a nice feature if you have a Ceph cluster with 90 hosts, something like this, and suddenly one of them just, the rate controller stopped working, restarted, and came back again. That's also, something like this. You should keep it stupid simple, avoid it, then you have not to tackle these problems. And why it took over a year? Because I think we had to update the firmware of the rate controllers 5 times, always with the promise that everything is fixed. So I think we can spend our time with something else better. Yeah, and as in the previous talk as well, we had seen some problems also with multiside for power users, like Bloomberg described before. We have seen this even a few years ago, and so we also recommend to say, okay, perhaps it's also better to solve some problems in the upper layer instead in the storage layer, because in the upper layer you have more information, so you can better control it, you can even stop it in the right way, and it's and you're perhaps also more flexible for the future. And yeah, and with RBD mirroring, especially with the journal-based version, some of them just forgot that if you enable this and if you use it, that you lose 50% of your IOPS. And that's sometimes not, I don't know why they realize it in production, because it should be visible even before when you test it. But yeah, something like this happened. And I think since a half a year or even longer, there's a discussion if snapshot-based RBD mirroring is really the best use case or a feature for some specific use cases like databases and so on. So keep an eye on it, which feature you want to use and which workload you want to run on it in production. Yeah, I mean, MDS replay mode. Yesterday I asked him how it's looked like with the bug that was there. So I think they promised that will be fixed in Reef. So perhaps not with the first Reef release, but with another one. Yeah. PG autoscaler, we had some nice experience as well. Nice means that I think this was even one of our clusters that autoscaler tried to increase the PG size to 8,192 or whatever, and we did not find the reason why it should be there. But the major topic with PG autoscaler is most of the time that it is from a design perspective, it's just reacting. So when you get load on the cluster, then it's recognizing, oh, I have load on the cluster, I need more PGs, now I put more load on the cluster, and then the otherwise, oh, now I have nothing to do again. Perhaps I do not need the PGs anymore. So our recommendation is to disable it and predefine it as well. Even at the beginning, for someone who's starting with Ceph, it's like this: if you don't have the right PG number on your pool, then you will not get the right performance, because it's essential that you have enough PGs already there before you start your performance test. Yeah, as mentioned before, the outbalance of the MDS in the previous versions, we disable it and do our own pinning, or recommend to do the own pinning. And yesterday I thought, okay, now the cache tiering is decommissioned out of Ceph since now I think 8 years, but it's still just marked as deprecated. I mean, a strict recommend, don't use RBD cache tiering in the version that is, I think, there since around about 8 years, because we tried it multiple times, we tested it several times, and then we said, okay, no, that is not a feature that you really can use in production. So, and yeah, the old story from since 10 years, yeah, don't use replication size 2, not with min size 1, and the next generation is don't use replication size 3 with min size 1. This I realized also in the last 2 years, and also the same with erasure coded with M-2. I think we had a quite famous company in Germany. They had a data loss on their backup system, because I just read it in the newspaper, and if you could read how it happened, the cluster was 5 years old, so the disks, the risk that the disk will fail increased. Then the first disk failed, then it started to recover. Then the second disk failed, it started to recover, and then the third disk failed, and then it was out of. I mean, something like this. you should keep in mind if your plan is to run it in 5 years, because the risk that it will come at the beginning is quite high in the first 2 weeks, because you see a lot of rotation is dying, I think, let's say in the first month. But then normally it's quite silent. But when you reach 5 years, or 6 years, or 7, then this number is quite important for you. Good. Yeah, and then also a really common topic is lift and shift. I mean, lift and shift I copied more from when you take your hardware or your software stack and move it just to a newer architecture. But we see mindsets from the past, some perhaps 20 years ago, that they say, okay, yeah, snapshot is a backup for us, it's efficient enough, and so on. In short words, normally we in our recommendation always say, if this is a production cluster, then you need a backup strategy, and if you don't have one, then we will create one for you, because I mean there is no 100% guarantee that that we will not hit a software bug or whatever. So also the underestimation of how Ceph is consuming, or what kind of resources Ceph needs in failure cases and so on, is for some operators not that really visible, because in a normal operation perhaps you have a load between 2 or 4 on a Linux server. Your Ceph monitor database is perhaps 500 megabyte, 1 gigabit, depending how large your cluster is. But someone we had a situation that all the capacity for the monitoring database was just consumed, because the database was 300 gigabyte, something like this in size. Because it also took a while before they called us. Sometimes they just ignored warnings because it was still somehow working, or they had something else to do. So and we also have seen that they also underestimate the topic of scrub data, because to deep scrub data is something that's growing. It's CPU. It's an exclusive lock. It's CPU intensive, and the time you need to complete a scrub is gaining over time. As more data you store inside, you need more time to scrub the whole data. Even if you do put a sleep between and so on, but you can see the impact on the clusters. And the other thing is also never touch a running system, and I only want to build one large cluster at the end. I mean, for the first one, this was the motivation why I have chosen cloud computing, because I said, my idea is that I should be able to reboot or touch any system at any time, and it should deliver my service. And the second one, I was a guy like this, I think until 2016, 2017, they said, yeah, we want to build really large clusters. But my recommendation is, you have to think, when you build a cluster at this size and you only have one, and you have customers on this cluster as well, your support team should be the same size that you can handle all the requests of your clients when they call you, when this cluster is perhaps not available anymore, or that you have that you not really can fulfill your complete SLAs. Also, we have found, I think it was called a peachy DDoP bug last year, together with some core developers, with our developers, with the help from CERN and so on. We somehow fixed it. It took a while, I think 6 months, until it was included in the Ceph release. But this was a typical bug I ever thought, okay, that's worst case scenario, that when you have a problem inside of the OSD, and then the OSD starts to consume so much RAM that it just will die. We have seen this bug over years, because I think the code is 8 years old. And yeah, we have seen it sometimes. It was just one single OSD that was affected at this time. But then we had in one of our internal all-flash clusters the chance to really debug it in detail, because this bug took a whole test environment down. And we tested it quite well. We stopped to give the OSD, I think, 500 gigabyte, because it still was consuming RAM. Normally in production you don't have the time to that your cluster is down for 2 weeks to analyze it and find the root cause of it. So from risk and high availability perspective and so on, it's sometimes perhaps better to think about to have a second or even third cluster instead to build one big one, and because just the numbers are so great to show, oh, I have now 5 petabyte, 13 petabyte, whatever. So I keep it short, so open for questions and or feedback. So, sorry.
What is a large cluster? How large is a large cluster?
I mean, over the years, they shrink a bit. But a large cluster, I mean, I would say large cluster begins at 2,000, 2,500 OSDs. So something like this. But I mean, it's I mean, large cluster. I mean, at the moment, a large cluster could be 300. I mean, I would define it. The OSD count is going down because the disk size is growing. If you have this on HDD, that's we see. And large cluster, I mean, it could be 100, depending on how you operate it. I mean, our goal is normally that we integrate everything, that we don't build silos, and that you have a relaxed time as an operator, and that you can focus on something else. And there are always some critical situations, depending what you run, and then it sometimes makes life easier that you know, okay, there's a second, a third cluster, and so on, that also can provide the service to someone else, and you just can do the upgrade there. Imagine if perhaps C-Store and Crimson will appear, and then you have to recreate all your OSDs, and who knows how long this will take. If you have done this between Firestore and BlueStore, that can take took a while, and it gives you just a bit more flexibility and also more options how you can operate, I would say.
So it's just in general, it's better to have multiple clusters to like balance the load more instead of just relying on one cluster.
Yeah, I mean it's not a general recommendation, because for sure some labs has really large clusters and they are happy how they run it, but they have perhaps different SLAs than someone else.
Well, actually, I noticed that you had a very good point in terms of the definition of large, is that it needs, in case of a major incident on your Ceph cluster, you need to make sure it matches, I mean, the impact should match your support, your team behind it.
Yeah, that's also the...
that's a very good point, I think.
Yeah, that's one of our goals, that we say, okay, that's a technology stack, but it has to be fit to your demand and should be integrated in your existing environment, because greenfield is not that often. We showed the visibility, but the decisions and how you adapt to it, I mean, that's normally a discussion with the customers. Yeah.
Oh, I have the mic. Oh.
Hello. Thank you for your talk, by the way. It was very, very informative. I was wondering if you could say a bit more about the kind of optimal MDS count, and particularly with regards to active versus replay.
Okay. So active replay at the moment, I would say the optimal count is 0. And MDS, yeah, I think we also had yesterday the discussions. MDS is, from my perspective, in short words, is multi-threaded, but acts more like a single-threaded process. You need a lot of RAM. We have, I think, between 64 and 128 gigabyte of RAM. I think 2-3 years ago we had some customers, they used 180. I think, if I remember correctly, I don't know the version anymore, but that was not, so the whole RAM was not used by the MDS anymore. And I say, at the moment, I would say with Quincy, we try to keep it somewhere below 16. But it depends really on the load, what kind of load you have on this. For example, we had one Ceph cluster that holds, oh my gosh, I think it's 300 million emails or something like this. And we need 8 to 10 active MDS for this. And most of the time it's just because Dovecut, before it creates the final file, it has a temporary file and renames it. And that's not that nice on Cephfs. So, but yeah, so it really depends on your workload. And I think also yesterday in the developer summit it was mentioned that to run Postgres at the moment on Cephfs, perhaps you should test this quite well. Yeah.
Thank you.
What would you say is the minimum viable size for a Ceph cluster?
Okay. So, I mean, I know from customers they have the minimum size they run over years is 3 OSDs. Really 3 disks, but I mean that's a special case. In the virtual environments, so AWS, GCP and so on, I think we have customers overall, they run 300, 350 Ceph clusters there. It is with the modification of OSDs, how they allocate memory and so on, so it's not really a standard default configuration. We convinced them that it should be 12. But it has more to do with how, for example, Azure works and some other internal stuff of the hypervisors. A minimum, yeah. So depends on the load, on your use case and so on. But I would say, hey, if you really want to start and you want to scale and you want to use it in production for the next few years, 24, something like this. But that is something, yeah, that it has to be discussed. But the other way you could, and I can answer the discussion, before you buy one SSD with 7 terabyte, perhaps you should think about, is it cheaper to buy 2 or 3 with a smaller sizing? Is this okay, the answer?
Yeah, my question was like for small data centers, open things like that, 3 nodes, 5 nodes.
Okay, so node, yeah, I mean, a lot of companies think that 3 nodes is sufficient enough. I always recommend 4 because you have to think about that perhaps one is dying. I always want to have replication size 3. I will want to have my complete data consistency. That's for me the most important part. That's even the reason why I have chosen Ceph a long time ago, because it's strong consistent. And so if I want to run a Ceph cluster, I would normally choose 4 nodes. So, okay. Yeah?
Yes, I was curious, you touched a little bit on setting a wrong replication factor will burn you in the case that disk starts failing at a certain rate as they get old, for instance. And that has to do with Ceph takes time to recover from a broken disk.
Yeah.
It will take longer time if it's a very large disk. So disks do get larger and larger. You can get 20 terabyte disks. That's possibly not a good idea. Where's the balance there?
Okay. First of all, they are also the experience that they're getting slower over time. So not only that the disks are getting larger and so on, but it looks like for some specific disks, if you run them over time, 5 years, that they're getting slower over the time.
Is there an easy way to detect where you would have those things? We may have that actually, now that you mention it. How do you detect that? I mean, is there an easy way to detect that?
I mean, the easiest way I would say is just to run an Ceph, how it's called, Ceph tel bench on the single OSD. But the problem is, if it's in production, then it's not the right number. I mean, we have different strategies as well, how you bring hardware in the cluster and out of the cluster. So that normally we also say, okay, please don't use the default crush rule. Now we are going into the detail. How this standard tool set is developed is that it's always pinging to default root setups. And sometimes you don't want to have this because when you add a node and you execute this command, you bring it directly into production. You impact the actual load on the Ceph cluster because you called this command. And so we know we have something like a staging where you can test this. And what we also do upfront, normally when we do something like a burn-in test, so that we have the numbers of a completely empty cluster at the beginning and can compare them later over time. But that's not in this case because that's are not our customers. In this case, we know them because they just called us. In the other way, when you are a customer of us, then we normally do something like an onboarding. We verify everything that you have. We collect a lot of data, and we verify this all the time against our environments and the environments of all our other customers. So, but sorry. So, do you want to add something to this? Okay.
Okay.
The very large HDDs is a clear problem for Ceph. And don't forget that recovery happens in parallel across the cluster. So if you have a small cluster with just a few tens of OSDs, yeah, this is going to be a problem that is unsolvable. But in the large clusters with 500, 1,000 OSDs, right now we have 100 recommendations, 100 PGs per OSD, right? Familiar with this? So this means that when a disk fails, you have 99 peers recovering in parallel. So it goes 100 times faster than the size of the disk. Going forward, we need to push the number of PGs up, heading towards 300, 400. If you ask Mark Nelson, where's Mark? Is he in the room here? He wants to head towards 1,000 PGs per OSD. That's coming.
Yeah.
That'll be the solution to these many, like 20, 30, 100 terabyte devices coming soon.
Yeah. And the other way how you can think about this, you have to count what, if you have a 20 terabyte disk, is this now 20% of your whole capacity or a half of a percentage? And then you know it. No, and you're right that, of course, what you replaced rate with the logic of Ceph, and between a failure and the recovery, that's important for your data integrity.
Are you seeing the physical degradation with FIO, like pre-burning and like pre-setup numbers? And after 5 years, are you verifying it with FIO or in Ceph on the OSDs?
Sorry, I did not understand the question.
Like when you set up a new cluster, you FIO all the devices, you get a baseline.
Yeah.
And you said you're seeing degradation. Are you seeing this with FIO, and is it verifiable?
In this case, so we do FIO, but we do several other stuff as well. But we also use the OSD bench, so that we can just you move one OSD out of the root, and then you test it, and then you bring it back again. Or you can do it with a whole host, depending how many you have. But with FIO, it's too, yeah. yeah, I mean, you have to complete it, delete
Yeah,
the
just-
OSD and
yeah,
so on.
you have to
So,
inject
I mean,
it, but just wondering if
you-
it was.
yeah, you're searching for
verifiable.
so you try to find indications for something, and then when you have there something, and you, for example, in some cases, they're slowing down the smart results, okay, but still you know that when you compare to a year ago, that's something changed. Of course, then you think, data structure inside of Ceph and so on. Then you analyze the latency, perhaps like Mark Nelson is doing it with the performance. You can think about it, and then you come closer to the point. Oh, it is the hardware or the single disk. And even, I mean, if you have one single disk that's slow in the cluster, it's not perhaps not that easy to find at the beginning, but you see the impact directly. Yes. Yeah. 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 Yeah, but we had use cases like this that we started with 4 to 5 nodes, and then we scaled it up online to 115, I think, or something like this. So, yeah. Yeah, I mean, this type of cluster we did, there was no autoscaler, so we had to do it manually. The interesting part was Dan wrote the same scripts at CERN like we wrote at Clyso at this time to somehow bring the PGs step by step up and up. Because at the first try we did, okay, let's set it up 2 times PGs. Okay, 20 hours later you can use the cluster again. So nice experience in the past, I think, and you see the results. I mean, PG Autoscaler has his need, and it's good that you can increase and decrease PGs, but this automated way, I would not recommend it. Okay, yeah.
In your opinion, what would be the optimum the number of monitors in terms of the cluster size? For example, if you have 100 or 500 loads, OSD loads, what would be the optimum number for the monitors? Or
okay.
For example, 10 or 100? I don't know.
I think someone told me that someone installed a cluster with on each node a monitor. I think that's too much. No, so we are talking about new versions. So when the manager was already introduced, new versions. Normally 3 monitors are enough for 500 nodes. You can do it you can have 5. I mean, the footprint of the monitor is not that high anymore after they removed the manager or created the manager. And the footprint, I think, also perhaps will decrease again when perhaps the team decides that they will not write logs to the Mon database anymore, because we have seen this as well when this was introduced. It was that when you join a monitor under load in a cluster that's not in a healthy state, that you have CPU load of 100%. It takes 5 minutes that the monitors can join his Chrome again. Normally before it was, in regular cases, it's milliseconds, I think, or a second or something like this. But back to you, 3 monitors are sufficient enough for 500 OSDs. If you use 5, it's also not a problem. 7 at the moment, I don't see any reason, and if you go way up, then you have only disadvantages. So. Sorry. Okay. No. Yeah. I mean, just in general. I mean, caching at all is just helping you in a short term. I mean, if you can, you can see it in. I mean, in RBD, Bcache, and flash cache, and also in caches and switches and so on. That's quite efficient as long the cache can hold the load. But if you go over this, it's has a really negative impact. So that's my general answer to it. The cached here, I think the problem is that you can end up in situations when you want to remove it again, that it's not possible. So the last time when we did it, we could not get rid of it anymore. I mean, I know that there was sometimes they use the cached here that you can migrate between pools and then you replace the pool and then you move it out, but you live with the risk that you're stuck, that you will not come out of the situation anymore. And I think yesterday also someone shared the experience that data disappeared when they disabled the cached here. Then the data disappeared and then they enabled it again and then was there again. And I think there was also a specific object. I think it was called white draw. I can't remember the name. We have seen this as well once in the cache here. So it's just a general recommendation if you want to run a stable cluster. I mean, I have seen too many different interesting approaches. Out? I think SUSE was the only one, or that was yeah. But I mean, in the documentation, it's still there. It's still in the source code. I think they will, or they have it set to deprecate it. I think they told us yesterday that they will do it. And I thought just yesterday in my mind when this happens, that the cache here is out of the source code, I will spend everybody a beer because that's because I know it for so long and good.
Caching. Do you?
Last question.
No. Have you had any success, or know anyone that had any success with deploying like HDD clusters with SSD for RocksDB and WAL, and then doing some tuning with deferred writes to accelerate like little bursty improvements in bursty write?
I mean, to simplify it, I think the SSD is so cheap at the moment, or is so. We always recommend buy a bit more hardware, spend a bit more money, and at least run it in a mixed mode, but not pure rotational disks. Because I mean, it's a cost topic as well. I mean, when we work on this for someone, that's then more expensive than instead buying a bit of hardware.
Yeah.
That's also for Joule. When it's possible, we also recommend the customer when the hardware is even 7 years old, we help him to live migrate everything. But to upgrade Joule is a challenge.
Yep.
Even to just remind, how was it in Joule, and how often I have to recreate the OSD and so on. There was LevelDB before, and file store and so on and so on. So yeah.
Cool.
Okay. Then thank you very much. Enjoy the event.